Okay, so today we're looking at our last section in geometric vectors, which is rectangular components. And this actually leads us into our next unit, which is Cartesian vectors. So, just remember from last section, rectangular components mean components that are perpendicular to each other that add up to equal the resultant. So it says any vector can be resolved into rectangular components. So example, write the vector below in rectangular form. All right, so we have two components here. So we have the y component of the vector, so we'll call it our y, and we have our x component, which is our x. Okay, and now to determine this, we use our trig ratio. So we have that sine theta is equal to ry over r, which means r times sine theta is equal to the y component of the vector, and similarly r times cos theta is equal to the x component of the vector. So in reality, there are many forces to be considered when determining resultants. A simple example would be current and wind affecting the motion of a boat. In more complicated cases, it is easier to solve a vector-related problem by using rectangular coordinates. So to determine the resultant vector, in this case, we simply add the x components together and the y components together, then determine the resultant. And this avoids a messy diagram if you have more than two vectors. All right, so first example, a 10 kilogram box is at rest on a ramp. Okay, that is inclined 30 degrees to the horizontal. Resolve the vector into its rectangular components that keep the box at rest. All right, so no problem here. We will draw it out. So we have our ground. We have our ramp, which is at 30 degrees, and then we have a box on top of the ramp, and then we have gravity that is pulling this down, and the force of gravity again is its mass times 9.8, so it's going to be 98 newtons. Okay, now we're going to resolve this because it's at rest. Gravity is pulling this down, so there's two forces that are resisting this, right? So think about if you're standing on flat ground, gravity is pulling you down, but the earth is pushing up with the exact same force. That's called the normal force, which is perpendicular to the ramp. So we have our normal force, which is here. And then we have our force of friction, which is keeping the box at rest as well. And then we have our force of friction. Okay, and that opposes the motion, but it doesn't actually matter. We can just do it like this. That's fine. That's good. All right, so those are the two forces that are keeping the box at rest. Okay, now we're just going to use some basic trigonometry skills here. So if this is 30, that means that this is 60 here. Now if this is 60 here, we have our Z pattern, so that means that this is 60 here, and this one right here is 30. Okay, and we're going to call this perpendicular force, the normal force, so Fn, and we're going to call this Ff for force of friction. Okay, and now we're just going to figure out each one using SOHCAHTOA. Right, so we're going to have cos 30 is equal to our adjacent, which is Fn, over our hypotenuse, which is 98, and then just multiply. So we have 98 times cos 30 is equal to Fn, and we get Fn is equal to 84.9 newtons. Okay, and then the other one is the force of friction. So we're going to have the sine of 30 is equal to the force of friction over 98. Again, just multiply. So 98 times sine 30 is equal to the force of friction. And we get the force of friction to be 49 newtons. Okay, and done. Perfect. All right, next example. Okay, a golf ball is climbing with a velocity of 300 meters per second, an angle of inclination of 40 degrees. Okay, no problem. We'll draw the ground, and we'll draw our golf ball going this way here. Angle of inclination is always measured from the horizontal upwards, and we have 300 meters per second. Okay, so now we're just going to break this down. So this 300 meters per second, it's rising at a certain speed, and it's going along the ground at a certain speed there. Okay, so we'll just call this velocity in the x direction and velocity in the y direction. Okay, no problem. So again, it's just using our trigonometry. So we have cos of 40 is equal to Vx over 300. So 300 times cos 40 is equal to Vx, okay, which is 229.8 meters per second. Okay, so if you're watching the distance, that's how fast it would look like it's going along the ground. And then we have 300 times sine of 40 is equal to Vy, and we get Vy to be 192.8 meters per second. So this is how quickly it's climbing vertically. All right, nice. And our last example. Okay, so this one right here, again, there's only 2 vectors, but if I had like 4 or 5 vectors, like this hiker kept changing directions, it'd be much easier to break it up. I'm going to show you how to break it up into component form. Okay, so the first one is the hiker travels 500 meters north 30 degrees east. Okay, so we'll draw our sort of axes first. There we are. And we are going 500 meters north and then 30 degrees to the east. That's our 30 there. And then we have our x and our y. All right, we'll go back to this color here. All right, so perfect. So we're going to figure out the distance in the x direction and the distance in the y direction, if that is 500. So we'll call this displacement y, displacement x. Okay, so starting off here, we are going to have sine 30 is opposite, so distance x over 500, and we're going to multiply. We're actually just going to leave it like this for now. 500 sine 30 is equal to distance x, and similarly 500 times cos 30 is equal to distance y. I know this is different than the previous. In the previous example, x was cos and y was sine, but just because the way we drew the diagram here, we put the angle there. Okay, so if we would have put the angle here and put this as 60, right, then we would have did the other way. Okay, so this is the component form. Okay, so that's our distance x, distance y, and now we're going to do it for the next leg of the journey. Okay, and the hiker is going to go 430 south, 10 degrees west. So this way here, and this is 10 degrees. So again, we have this and this here. So we have our distance y and our distance x, and this is 430. Okay, so we are going to get sine 10 degrees is equal to dx over 430. So 430 times sine 10 is equal to dx, and 430 cos 10 is equal to distance in the y. All right, now to get the total distance, all we do is we add our distance in the x and our distance in the y. So our final distance in the x is going to be, and I'll figure this out to the nearest like 100, sine 30 plus 430, or sorry, it's actually, these are both negative, right? Because it's in the negative direction. Okay, so minus 430 sine 10. Okay, and we are going to get 500 sine 30 minus 430 sine 10, and that is 175.33 in the positive x direction. Okay, and then our dy is going to be 500 cos 30 minus 430 cos 10. And that is 9.55 positive. All right. So now to get the resultant, all we're doing is sort of essentially Pythagorean theorem, right? So we're going to go like this and like this, and we have our two vectors. We have our 9.55, which is here, and then we're going up 175.33, and then here is our resultant. Okay, so the resultant, magnitude of the resultant is equal to the square root of 9.55 squared plus 175.33 squared, and that's equal to 175.6, and then the angle is inverse tan of 175.33 over 9.55, which equals 3.11 degrees north of east. Okay, and there are your practice questions.